In the previous video, we saw this logically correct proof by contrapositive. So for the last bit, and this will be the problem associated with today's daily challenge, I'll ask you, is this third proof correct? But I will get you started in this video by identifying the assumptions and conclusions. So I think, at least for this video, this is the first proof we've had that has this if and only if, which is slash if, wrong slash if in LaTeX. And this means that the proof actually has two parts. We're saying that if you assume the left side that A is a subset of B, then it's true that A intersection B is A. And we're also claiming if you assume the right side that A intersection B is A, then the left side is true, that A is a subset of B. So the proof has two parts. You claim left implies right, which is the forward direction, and you claim that right implies left, which is the backward direction. So I guess there's, just to make that completely clear, there are two subproofs in here that one would need to establish to show that this claim is true. So the one assumption, the assumption of the first subproof assumption is that A is a subset of B, and conclusion is A intersection B equals A. The second subproof would need to have the assumption, which is reversed. So this is actually the converse of the original statement. So assumption A intersection B equals A, and conclusion is that A is a subset of B. So as you read this proof, note that for the proof to be logically correct, it needs to first do this part, assume this thing, and prove this thing. And second, it has to do the backwards direction, right implies left, which means one assumes this and proves that this is true. And then we're almost done, but I'll just remind you that there are definitions of intersections. So for instance, the definition A intersection B is the set of all x such that x is in A and x is in B. We remember the definition of subset, so A subset B means that if A is in A, then A is in B. So those are two definitions that you'll need to remember. The third thing, and I'm almost out of space, but the third thing you'll need to remember is that to claim that two sets are equal, right, because part of this proof involves showing that two sets are equal. So the third thing you need to remember is that to show two sets, which maybe I'll call them x and y, because we already used A and B, to show x equals y, we show two things, x subset y and y subset x. So just try to keep this all in mind. As you read the proof to tell if it's correct, you should be looking for two pieces. One piece should assume A is a subset of B, and then it should show these two sets are equal, but that subproof itself has two sub-subproofs, right? Because to show two sets are equal, we have to show each is a subset of the other. So this first proof should have two subproofs. The second subproof should assume that these two sets are equal, and then prove that A is a subset of B. So that second one doesn't have two sub-subproofs, because to prove the conclusion, we just need to use this definition down here at bottom right to show that whenever A belongs to A belongs to B. Okay, so try to read through that proof, ask yourself if each deduction follows from the previous assumptions, and check to make sure that all of the necessary subproofs and so forth are there and are logically correct.